Well, hello and welcome. It is time once again to do our very best to try to fix something. And today on the workbench, we're looking at another PS5 Blu-ray edition that has no power. It's supposed to not have no power, and I think it does. Now, I did get this off of eBay, and I do know for a fact it has been worked on. It actually came from another electronic repair shop. And it actually has a note on the side of it. No power, no beep, no liquid damage, repair attempted. Reflowed south bridge. So we know someone's been way into it, and we know the south bridge has been reflowed. But what the heck? I got it plugged in. Let's just see. Is it gonna... Very, very dead. Okay, so we're very, very dead, and we know that they've been in there and they reflowed the south bridge. That's what we're starting from. Let me get some covers off. And I'll probably just go ahead and take that board out. We'll take it inside. We know it's dead. We just got to figure out why it's dead. So let me get these covers off. And if I don't find anything too surprising, I'll just see you in there at the workbench. Well, here we are inside at the workbench, ready to take a look at this PS5 main board, which this is an EDM33. And I can confirm that there is flux around the south bridge, which no surprise. So yeah, that's definitely been touched. I think what I want to do first is let's just apply 12 volts to it, and let's just see how much current it draws on the bench power supply. It's as good a place as any to start. I've got my leads connected correctly, I believe. Let's just see how much current we draw here. Okay, we're stuck at 11 milliamps. Our south bridge is not initializing in any way, which means it's either dead or that they have left flux underneath it. And if they leave flux underneath it, this 32 kilohertz oscillator right here will not be able to run. So yeah, let me see if that's what's going on. That may be, it could be we're missing some power rails. It could be because I believe we're going to need at least like 3.3 and like a 1.8, a 1.1, somewhere in there, I can't remember. For this thing to try to run, which comes from this little IC right over here, which is either the DA9065 or the RT5126 or something like that. Anyway, that chip, which does not look like it's been changed out. This chip looks to be the original. So yeah. All right, let me try cleaning out from under the south bridge first, just to make sure that's not the problem. And then we'll come back and see if it tries to boot at all then. Alright, after flushing out from under that IC, let's see if we've done any good whatsoever. Got my leads reconnected. Get my scope out of the way. What do we do now? No, we're still stuck at 11 milliamps. Alright, so what I'd like to know, our battery is in here so we don't have to have this. Is that 32 kilohertz oscillator running right here? Dig out a scope probe. Let's see if we can do this. Good place to connect the ground. Just right over here would be good. Since the battery is on this thing, if that's a good battery, this oscillator should be running right now. And I can't tell. I think there's something there, but I need to adjust my scope. Just a second. Let me adjust the scope. I'm out of hands. Just a second. All right, and I've got my probe on the crystal, and I'm going to say yes. Our 32 kilohertz oscillator is running and appears to be on frequency. So that's not our problem. So if that's not our problem, I need to make sure that we have all of our supply voltages into this thing, into this south bridge. And if we do, then we may have a software problem. As in the contents of this flash memory I see right here. But let's not get ahead of ourselves. Maybe it's not that bad. Let's just see if we have all of our rails, or if we have a short under the south bridge. All right, let's take a look around the area of the south bridge. I'm looking at the back side of it on some of these inductors going in here, and I've got my meter in resistance mode. Let's just see if anything jumps out at us. Like here. Now we're in the K ohms. K ohms. I'm checking on these inductors on the back side here. These will all be power rails going in different places to the south bridge. And none of this looks bad at all. I need to look at some notes. I know I have some. Well, I did find my notes relating to this RT5126 chip. I don't really think that's our problem, but we might try to eliminate it if we could here. Let's do some diode readings around this chip. See if we can quickly eliminate it. All right, this first one is ground, right? Pin 2 and 3. That looks pretty close. Let's go to pin 4. Yep, pretty close in the ballpark. How about pin 5? Yep, I'd say that's good. 6. Yeah, 7. Pin 8. Yeah, let's keep going. Pin 9. That's acceptable, I would think. Pin 10. Yeah, how about 11? If I can get in there. 11. 12 looks to be ground. 13. 14. 15. 16. Looking good so far. 17. 18. 19. And 20 are the same connection. 21. 22. And 23 are the same. 24 looks to be ground. 25 and 26 are both the same. I believe 27 is a no connect. Yeah. Here's 28. 29. 30 is also a no connect. And then 31 and 32 with a 1.15 goes out, I believe. Yeah. 0.325. All right, that looks okay. We're going to have to keep looking. I think we have to look someplace else. I think that chip is good. It doesn't look like it's been swapped out, and I don't think it needs to. Let's look someplace else. All right, let's take a look at another part of this circuit I'm curious about. Let me turn my meter off. We're going to use the scope for this one. What we're looking at here is the area between the flash memory IC, the NOR chip, whatever you want to call it, and the south bridge. And I want to see if there's any data traffic going on there when I apply power. Let's see, make sure I can get everything in the shot. Let's just take a look. These are 47 ohm resistors right here, all of them. And they're between those two chips. And I'm going to apply 12 volts to the board. Let's watch the scope. Yep, that looked like a burst of data. I'll do it again. Yeah, let me turn my gain down on the scope. It's kind of going off the top a good bit. Try that. Yeah. Does look like data. I'm going to go down to the next resistor here. Yeah, a little something going on there. Go to the next one. Small amount there. And here. I don't really see anything on this last one. But that to me says the south bridge is trying to do something. It's trying to load its software from that chip. The south bridge could be bad. It's not out of the question. But whenever I've seen one look this dead, like this thing's drawing like 10 milliamps or less off the 12 volt supply, it seems like it's quite often the contents of this chip right here. Like something has become corrupted and it can't load its software. And I can tell by looking at the solder, this has not been changed out. So I think what I'm going to do is pull that chip off, see if I can read its contents, and try to determine if it's corrupted or not. I think that's my next step. Fortunately, I was able to read the contents of the flash memory IC and recover needed information. I then used the BWE software, the NOR validator, to check for any obvious corruption. And sure enough, corruption did show up. Several, I think it was 5 warnings, 5 dangers showed up, which indicated there was definitely some corruption there. I then tried to use the BWE software to regenerate the NOR contents. And the software has 3 different methods, and I tried all 3. No matter what I did, the resulting file, whenever I tried to boot the machine, it would not work. It was set at 1011 milliamps. It would not load, the software would not load that bin file. So I finally just had to give up on that approach, and I found a file that I had recovered from another machine, one I had recently worked on, another EDM33 with a 69GG firmware, and I used that bin file that I had saved and put that on the IC. Alright, well, repairing the contents of that flash did not seem to work, so I have replaced the contents with one from a known working EDM33 with the 69GG South Bridge. I know it works because it was like I worked on it like 3 days ago, so I know it was a good firmware. Let's see what this does. Some stuff out of the way here. Yeah, there we go, 320 milliamps, and come back down. That looks normal. All right, so I think that'll make this board work, but I still want to fix the serial number, the MAC addresses, that sort of thing. To try to make it back as much like as it was as I could. But that's exciting to see. So it was corrupted flash memory. That's good to know. Well, here we are back out in the garage, and hopefully at a point of testing this. I was able to, using the BWE software, I was able to harvest the MAC addresses from the original BIOS, move those over. And I also moved the serial numbers over. So hopefully, this will be the same as the original firmware, only working. Let's see what happens. Well, that's good. I think I saw it lock. Come on. Still flashing blue. Oh, sorry, I see a white light. There's a white light. See? If we can get some video on this monitor. Do we have a bad HDMI? Try wiggling it a little. No. No video. That's an odd one. Not sure what's going on. I did not really take a close look at the HDMI port because that was the least of my worries. It wasn't even turning on. Okay. Maybe I need to take a closer look at that. Okay. All right, well, I tried bringing it up in safe mode just to see if it was a resolution problem, because this is just a 720 1080p type monitor. It wouldn't handle 4K, but I just had bursts of noise in safe mode, so I went to looking at the port. If I can show you, it looks like pins 1 and 3 are open. I get nothing. Pin 2, of course, is grounded, looks like. But 1 and 3 read open. Now, the rest of them, I think, are good. Like, let's see. There's 5. Or, I'm sorry, that's 4. That looks good. That's ground. I mean, the rest of them look good. It's 1 and 3. So, do we just have a broken port? This poor thing had 2 problems. I wonder if somebody, it wouldn't boot, so they decided to shove the connector in harder. I don't know. Let me get this board back out, and I'll take care of this HDMI issue. Well, the pins on this port look all right. It doesn't look like it's pushed in or anything. Looks pretty solid. However, back here, I can get that to focus. Our little HDMI output filters. One of them is busted. And I don't know if I did that. I don't think so. But yeah, there's our problem with our no video. So let me find one on a donor, and I will get that replaced. The rest of them look okay? I think so. Just that one. That's on pins 1 and 3. Alright, after replacing that HDMI output filter, ta-da, we have video. Excellent. And this thing looks like it has been initialized. Okay. Alright, let me get this thing buttoned all back up and we'll finish this up. Alright, well, this PS5 is fully reassembled and looks to be in a good, healthy condition. So far, so good. I need to get on the PlayStation Network and make sure it logs in. I think we can do away with this little sticker. Maybe. It's pretty tough. There you go. So it's all good now. Well, I hope you thought that was somewhat interesting, educational, entertaining, any of the above. If you did, please give me a thumbs up. And I will see you in the very next repair. So long for now.